Algebra 3, Chapter 7, Section 2, Verifying Trigonometric Identities. First of all, a conditional equation is one that is true for only particular values of x. For example, sine of x equals 0 is only true when x is a multiple of pi. An identity, on the other hand, is true for every value in the domain of the variable. For example, sine squared of x equals 1 minus cosine squared of x is an identity because it's true no matter what values you put in for x. To verify an identity means to show that both sides of a given equation are equal. And in order to do this, we cannot use our usual algebraic tricks because we can't assume they are equal. We're trying to actually prove that they are. So you can't add, subtract, multiply, or divide both sides of the equation or square both sides of the equation in order to do this. You have to work with one side at a time, and you can't go and shift things between sides. Instead, we'll use our identities and we'll gradually change one side until it matches the other. Sometimes it helps if you start one side and you get kind of stuck to start working on the other side and try to have them meet somewhere in the middle. Now first, these are some tips for doing this. The first thing you want to do is work with one side of the equation at a time, and it's usually better to start with the more complicated side first because a lot of times it's easier to make something complicated simpler than to go the other way around. Look for opportunities to factor an expression or to add fractions together or square a binomial or create a monomial denominator. Also look for opportunities to use your fundamental identities like the Pythagorean identities or the quotient identities. Note which functions are in your final expression. Sines and cosines pair up well, so do secants and tangents, secants and cotangents. And if all else fails, try converting everything to sines and cosines. That usually works. Always try something. Even an attempt that leads to a dead end can provide insight. So just not doing anything should never be an option. You should try something. Because sometimes you get so far down, you get stuck, but then you've learned something from what you've already tried. The rest of this video is just really practice with this. Try using the identities to change the left side into the right or the right side into the left. Pause the recording, give these a try, and then resume and we'll talk through them. Okay, what we did here is we changed tangent into sine over cosine and cotangent into cosine over sine. Well, they cancel and leave you with 1, so it was as simple as that. On the next one, what we're going to do is we are going to multiply 1 plus sine of alpha times 1 minus sine of alpha, and that gives us 1 minus sine squared of alpha, which is cosine squared. On our final one, we're going to change everything into terms of sine and cosine, and we get sine over cosine, actually not quite everything. We have sine over cosine times tangent over 1 over cosine. Well, sine over cosine over 1 over cosine, the cosines cancel, and you're left with sine, and it leaves you with sine tangent. Now keep in mind there are other ways to approach these problems, and these are not the only solution. These are one way what we're giving you here is one way to work it out. Hey, this one looks a little more complicated, but hang in there, be brave, pause the recording. Just looking at this, I would try factoring. And I know factoring with the fractional powers is a little rough, but I would factor out a sine to the 1/2 and a cosine x. Pause the recording, give it a try, and resume to check your answer. So if you factor out sine to 1/2 x cosine x, that leaves you with 1, because that's the entire first term, minus sine squared of x. Sine to the 5/2 divided by sine to the 1/2 is sine squared. Well, 1 minus sine squared of x is cosine squared. So we have sine to the 1/2 x times cosine squared of x. That's cosine to the 1/3 of x, and sine to the 1/2 x is the square root of sine x. Okay, here are 2 more to try. Pause the recording. Again, with the one on the left, I would try changing things into terms of sine and cosine. The one on the right, I don't know, there's a lot of different ways to do it. One thing I would probably do if I were starting this would be to give them a common denominator. A lot of times that can really help. Pause the recording, give it a try, and resume to check your answer. Okay, so we change secant to 1 over cosine, and then we give the two terms a common denominator. So cosine x becomes cosine squared of x over cosine x. So we have 1 minus cosine squared of x over cosine. 1 minus cosine squared is sine squared. And then they pulled one of the signs out front, and that's perfectly legitimate to do that. And you have sine x times sine x over cosine x, which is sine x times tangent x. Another thing you could have done if you got stuck at sine squared of x over cosine x is work with the right-hand side. Because if you turn the tangent into sine x over cosine x, you'll get sine squared of x over cosine x. So that would be a case of meeting in the middle. As I said with this one, a good idea is to get them into one fraction. To do that, you have to get them a common denominator, which will be the product of the two existing denominators. So we end up with 1 plus sine x squared plus cosine squared. Then we multiplied out the 1 plus sine theta squared. That's where we get the 1 plus 2 sine theta plus sine squared theta. Sine squared theta plus cosine squared theta is 1, so we end up with 2 plus 2 sine theta. Factored out the 2, you have 2 times 1 plus sine theta. Those cancel, and you have 2 over cosine, which is 2 times the secant. And try these. Pause the recording, give them a try, and resume to check your answer. For the one on the left, the tangent of pi over 2 minus theta is the same as the cotangent. So we have cotangent times tangent. Well, cotangent is 1 over tangent. So we have 1 over tangent times tangent, which is 1. For the one on the left, on the right, what you want to do is remember that the sine of negative y is negative sine y. And then you're going to multiply those two together, and you get 1 minus sine squared of y, which is cosine squared of y. A little more complicated here. What I would do in this case is, I believe I would multiply, here's a little hint, the top and bottom of that fraction under the square root by 1 plus sine theta. Pause the recording, give it a try, and resume to check your answer. So when we do that, in the bottom, by multiplying it out, we get 1 minus sine squared theta. In the top, we just have 1 plus sine theta squared. 1 minus sine squared theta is cosine squared. And when you take the square root of the whole thing, you end up with 1 plus sine over cosine. We have the absolute value there because it was initially under a square root, which means that it needs to be positive. For the one on the right, we need to remember that the cosecant of pi over 2 minus t is the same as the secant of t, and then convert everything to sine and cosine, and you end up with tangent. This one you want to do a little differently. What you want to do is you actually want to draw a triangle. And you want to pick an angle, call it theta, and label it. The side opposite theta will be x minus 1. The hypotenuse will be 4. Find the missing side, and then find the tangent of theta. Pause the recording, give that a try, and resume to check your answer. And you can see what I was talking about here. I drew a triangle, I picked an angle for theta, I labeled the opposite and the hypotenuse as x minus 1 and 4. I used the Pythagorean theorem to find a representation for the missing side, and then from there you just do tangent. It's opposite over adjacent, and you're done.